Yes, beta, all of you see, we are discussing about the in last class we are discussing about the combination of capacitor, and we are continuing from that class only. Combination of capacitor. Combination of capacitor. Now see here, there are two types of combination. First one is series combination. Series combination, and second one is parallel combination. Parallel combination. See here, beta. In physics, parallel combination means the electrical devices will get same potential. This is the symbol of capacitor. One is positive plate, second one is negative plate. First one is positive plate, second one is negative. First one is positive, second one is negative. Now these three capacitor, when their positive plate are connected at same point and negative plate are connected at same another point. This is called parallel combination. This is called parallel combination. So when this end is connected, when this end is connected with the positive terminal of the battery, and this whole negative terminal, they will be said to be negative terminal when this end is connected with the negative terminal of the battery. So this is positive terminal, this is negative terminal. It will supply charge, and this plate, positive charge will deposit it. Positive plate. With the positive plate of the battery, if it sends positive charge, your positive charge will deposit it. And by induction, negative charge will be induced. Since this is earthing, negative plate is made earthy so that this side positive charge may move to the earth. So this is first capacitor, this is second, and this one is the third capacitor. Now see here, what is the most important characteristics of parallel combination? If the voltage of the battery is V, for example, if the voltage of the battery is 20 volt, then this point will be 20 and this point will be negative 0. It means that first capacitor also getting 20 volt, second capacitor also getting 20 volt, and third capacitor also contains 20 volt. No. So we can say that whatever with the charge supplied by the battery, this is moves to the capacitor Q1. This charge distributed in three parts: Q1, Q2, and Q3. Q1, Q2, and Q3. In parallel combination, what is the first important point? All the capacitors. See here, series combination we will discuss later on. So see here, in parallel combination, all the capacitors gain same potential difference. Gains same potential difference. And see here, whatever with the charge supplied by the battery, this charge distributed into three parts. So applying junction rule, whatever the charge that is moved from here to here, it gets distributed. So Q charge distributed in three parts: Q1 plus Q2 plus Q3. See here, all of you, whatever with charge supplied by the battery, this gets distributed into three parts. Q1 charge given over the first capacitor, Q2 charge given over the second capacitor, and Q3 charge given over the third capacitor. So we may write like this. Now, you know this formula, C is equals to Q upon V. So what is the formula of Q? Q is equals to CV. Q is equals to CV. Q is equals to CV. What is the formula of charge? QV. So see here, what we have studied about the series combination, plus minus plus minus plus minus. If all these capacitors are connected like this, once again you see, all of you try to learn this one once again. One more was joined just now. Subham Gupta, better try to join with your original name, because I don't know if by your name you are not coming. I'm not, and if I will remove you from the class even after joining. Now see here, this is first capacitor. One plate positive, one may be negative. This may be positive, this may be negative. Now, what is parallel combination actually? One capacitor consists of one positive and one negative. We don't know. Two parallel plates are there. If we connect one plate with the second plate like this, and then second capacitor, if we connect the next plate with the third plate, with the first plate of this third capacitor. Such type of combination is called series combination. This is first capacitor, this is second, and this is third. Now, if this whole capacitor, these three are connected with this terminal is connected with the positive terminal, and negative, this terminal is connected with the negative terminal of the battery, then what will happen? Since this is positive terminal, so here positive charge will be deposited. And by induction, same amount of negative charge will be deposited. Here plus Q, so by induction, same amount of charge minus Q. Since this is a metallic conductor, so charge induced will be equal and opposite. Negative, here positive charge will be induced, because by the induction in conductor, equal and opposite charge induces. Minus Q. Here plus Q. And here minus Q will be there. But see here, what will happen? In series combination, charge on each capacitor will remain same. Now see here, what is the next step? Whatever be the voltage supplied by the battery. For example, see here, beta, Subham, you have just joined, just see here. Beta, if the voltage of the battery is 100 volt, let's assume this is 100 volt. If the fall potential across the first capacitor is 30. It means that this is positive terminal, here 100 volt will be there. This is negative terminal, here 0 volt will be there. If 30 volt falls here, so from out of 100, if 30 falls here, how much remaining? 70. Now let us assume through the second capacitor, if fall potential is 35. Now, out of 70, let this be fall potential is 45. Now, how much remaining? How much remaining? Through the second capacitor. How much voltage? How much voltage drop occurs? 45. So, out of 70, you just subtract 70. 45. How much remaining? 25. So 25 volt remaining here. So across the last capacitor, 25 volt drop here, and here 0 volt. So type of combination we do in any circuit in practical sense. Now see here, it is let fall potential across this one is 30 volt, that is V2 charge of V1. Across the second capacitor it is V2, and across the third capacitor it is V3. So we can write whatever be the voltage supplied by the battery will be equals to sum of fall of potential in first plus fall of potential in second capacitor, the fall of potential in third capacitor. It should be clear to you. In all kind of series combination, either it is resistance, inductor, or any kind of electrical device. If in electrodynamics we are talking about the series combination, it means that the total applied potential will be equal to sum of fall of potential across the different devices. That's why we have written applied potential by the battery will be the sum of fall of potential across this one plus this one plus this one. Now see here. What is here? As we are talking, what is the formula of capacitance is equal to Q upon V. So we can write V tag here, and we can write Q upon C. Not everywhere. What is the charge on each capacitor? First one is Q upon C1. What is the capacitance of first capacitor? C1. Second is C2. Third one is C3. Charge on all capacitors are same. So that's why we write like this. C3. And what is the charge supplied by the battery? This is again Q. That is deposited here. Now it is Q upon total sum is C equivalent. Now see here again, both sides Q cancel out. What is remaining here? 1 by C equivalent. Equivalent means total sum of the circuit. Capacitance, equivalent capacitance of the total circuit. That is called equivalent. 1 by C1, Q both sides we take common and cancel out. Plus 1 by C2 plus 1 by C3. So, but see here in class 10 you have studied about such formula for parallel combination, where in case of capacitor this is just reverse. For series this formula comes out. In case of resistance this formula we have find out for parallel combination, but in capacitance this is just reverse. Now let us solve some numerical problem related to this one. Let us see here, if three capacitors are connected in series, this is 6 microfarad, first one. What is the capacitance? Second one, 3 microfarad. And what is the capacitance of third one? 2 microfarad. Now, what is the effective capacitance of the circuit? First one. What is the voltage supply? 20 volts. Find C equivalent. Find C equivalent. First question. Now, beta, tell me how we can solve. Since all are connected in series combination. Since all are connected in series combination, so what is the formula of C equivalent? 1 by C equivalent is equals to 1 by C1 plus 1 by C2. You see the previous case, we have find out derived this formula for parallel. Now for this series, and this such type of inverse resistance formula we apply for parallel combination, but for this is applied for series combination in capacitor. Plus 1 by C3. Beta, what is the first one? 6. Beta, put कीजिए 6 microfarad. यहाँ क्या बेटा? Second one 3 microfarad. Micro means 10 power minus 6, and farad, capital F is the unit of capacitance. Cap F farad. 1 by C3 is 2 microfarad. Now see here. What is the LCM? 632 6 microfarad. Divide this 1. 1 into 1 1. Divide this by this. 3 2 ja. 2 into 1 2. Divided by this. 2 3 ja 6. 3 into 1 3. So what is your answer? 1 by C equivalent. But 32516. 1 by C equivalent is equal to 6 by 6 microfarad. But see here, 6 cancel out. 1. You have to find this one. C equivalent. That is the equivalent capacitance of the circuit. So you have to revert this equation. You write here, by reverting this equation, we get C equivalent upon 1. That is C equivalent is equals to 1 microfarad. 1 microfarad by 1. That is C equivalent is equals to 1 microfarad is the equivalent capacitance. Now better see here. What is the second question asked? Determine the charge on each capacitor. Determine the charge on each capacitor. Then how you can determine? Let's see here. Better see here, in series combination, charge on each capacitor are same. In series combination, charge on each capacitor are same. What is the C equivalent? We can draw this circuit by putting equivalent sign here, and draw this circuit by single capacitance C equivalent 1 microfarad, and same battery. What is the voltage of the battery? 20 volt is the battery. Now you can remove this circuit. You have drawn equivalent circuit. 3 lines. It means equivalent circuit. So what is the charge supplied? That will be deposited over the positive plate, and same amount of charge will deposited on all the three capacitors. Because in conductors, equal amount of charge induces. In the beginning chapter, thus in the beginning chapter, we have already studied about the reduction of charge by induction. In conductor, induced charge is equal and opposite. That's why Q, same charge. Now see here, what is the value? You know the formula. C is equals to Q upon V. Here, C Q equivalent. What is the C equivalent? What is the capacitance of this circuit? 1 microfarad. Micro means 1 microfarad. Q. What is the voltage? 20 volt. Micro means 1 into 10 power 6. What is the unit of farad? How we can write farad? C is equals to Q upon V. What is the unit of charge? Coulomb per volt. You can write coulomb per volt is equals to Q. And 20 comes this side. 20 comes this side. What is 20 volt? 20 volt is equals to Q. Now see here. You can solve this. VB cancel out. 20 into 10 to the power minus 6. Micro means 10 power minus 6. 1 micro. Micro means 10 power minus 6. Now remember C for coulomb. So what is the charge? 20 into 10 to the power minus 6. You can write this one 0. 20 into 10 power minus 5 coulomb is the charge stored on all the capacitors. Now see here, beta, we will discuss next one. Now comes to the next question. Beta, see here. First capacitor, second one, third one. This is third one is again 2 microfarad. Second one, same capacitors are there just in case of the previous one. This one is the 3 microfarad and first one is 6 microfarad. But here all are connected in parallel. Now what is the equivalent capacitance? What is the equivalent capacitance? And the voltage of the battery is same. V is equals to 20 volts. What is the C equivalent? Since all are connected in, find C equivalent. Find equivalent capacitance. This is the question. So you know that since how they are connected, this is positive terminal. So positive charge will move here. Positive charge will move here. Positive charge will move here. Since all the positive charge plates are connected at same point, by induction same negative charge produces here. Negative charge minus Q, minus Q, minus Q. Negative charge connected at same another point. Such type of combination is called. This is the symbol of beta what? Capacitor. This is first capacitor C1. This is second capacitor C2. This is third capacitor C3. All are connected in parallel. What is parallel combination? Beta, when therefore all the positive terminals are connected at same point and negative plate are connected at same point, same another point. The step of combination is called what? Beta, इस connection को बोलेंगे parallel. और parallel में we have derived this formula. Since the combination is in parallel. So what is the equivalent formula we have derived? Equivalent capacitance formula we have derived? C1 plus C2 plus C2. So this is very easy. What is the first one? 6 microfarad. Micro means you remember 10 power minus 6. C2, 3 microfarad. And C3 is what? 2 microfarad. 2 microfarad capacitance. 6, 3, 9, 2, 11. So total is 11 microfarad capacitance. Yes, but see here, this is very easy. If in case of parallel combination, you are asked to determine the capacitance, you can simply add this one. 6, 3, 9 plus 2, 11. But just like in series, the charge on all capacitors were equal. But in parallel, charge will be different. Over the first one, it will be Q1. Over the second one, it will be Q2. Over the third, it will be Q3. Why, beta? Because you know, B is equals to Q upon C. Q is equals to CV. Since all are getting same potential, but their capacitance are equal. They are getting same potential, but their capacitance are unequal. Then the charge will be different. If their capacitance will be same, 2 microfarad, 2 microfarad, 2 microfarad, or it may be 6, or it may be 100 microfarad. That is, if all the capacitors contain same capacitance, then only voltage is also same they are getting, their capacitance are equal, then only in that case the charge that will be deposited over the positive plate would be same. But all you are getting, everybody, just show your response. Yes, everybody getting. Beta, charge deposited on all the. Very good, beta, Utkarsh. Yes, everybody, Devesh, be concentrated. Yes, beta, good, Devesh. चलो बेटा, तो पैरेलल कैपेसिटेंस में क्या समझेंगे बेटा, सारे कैपेसिटर्स को डायरेक्ट इक्विवेलेंट कैपेसिटेंस निकालने के लिए सम अप कर देते बेटा, 639 प्लस 211, और सब पर चार्ज निकालने का फॉर्मूला सीवी लगाएंगे बेटा, Q is equals to CV. तो बोलो बेटा, फर्स्ट कैपेसिटर पर चार्ज क्या होगा, Q1 is equals to C1V. Second capacitor per charge क्या होगा बेटा, it will be C2V, and what will be the charge of over the third capacitor, that is C3V. What is the capacitance of first one is 6 micro, write down micro, or may leave that micro. Micro means 10 to the power minus 6 to be already. And volt, what is the voltage? 20 into 6, 120 micro. What is the unit of charge? Coulomb. 120 microcoulomb. What is the charge on the second? What is the capacitance, beta? Q is equals to CV. Beta, very simple. You always remember this formula, Q is equals to CV. What is the charge capacitance of the second capacitor? 3 micro. Micro means 10⁻⁶. What is the voltage? 20. 23 is 60 microcoulomb. Beta, farad, you know. Farad is coulomb upon volt. And here 20 volts. We cancel out. Coulomb remaining. That's why we are writing coulomb. Microcoulomb. It is answer is what is? 60 microcoulomb is the charge present over the deposited over the second capacitor. Now what is the charge deposited over the third capacitor? Q3 is equal to C3V. What is the capacitance of third capacitor? 20 micro. Farad. Remember, coulomb upon volt into what is the voltage? 20 volt. VV unit cancel out, coulomb remain. Mic 20 into 20, 400 microcoulomb charge deposited. So what is the charge deposited over the third capacitor? Now see here, what is the formula you have got this time? Beta, what is the charge deposited here? 120 only. What is the capacitance? 2. But here 2 micro. Third capacitor is 2 only. 2 into 20, this is 40. So in parallel combination, more will be the capacitance, more will be the charge deposited. Maximum capacitance is carried out by the first capacitor. So maximum charge deposited. How much? 120. Less than this is the capacitance over the second capacitor. What is the charge? Capacitance 3, so charge will be slightly lesser, 60. And in comparison to this two, the minimum capacitance is C3. So charge present on the third capacitance 40 microcoulomb. So in this way we can determine the capacitance of series and parallel combination. Now see here, in tomorrow class everybody will present, because tomorrow I will give you the example of so many complex circuits. This is the very simplest one. And in our next class, we will discuss about the complex circuit. One very simplest question I am giving you. Tell me all of you. Yes, beta. Who will tell? Yes. Aryaman, beta, tell me how these three are connected. Just wait. How they are connected? In first look, what they are appearing? Plus, minus. Plus, minus. How they are connected? Tell me, beta. C1, C2, C3. Series they are connected. Plus, minus, plus, minus, plus, series. Now, how they are connected? I have made it short circuit. Short circuit. Short circuit means through the wire, I have connected this point to this. Potential of this point equal to this. Potential of this point is equal to this. So this becomes negative. So this will be negative and these two plates will be negative. Since this is positive, plus charge will go here. Through this positive charge will go and this will be also positive. So see here, beta. First capacitor, positive terminal, second capacitor, positive terminal, here negative charge will be there. All the positive terminals are connected at the same point and negative terminals are connected